Hey guys, welcome back. In this lecture, we will talk about numerical Python. Numerical Python is one of the most useful library or packages that was used for data pre-processing. In order to pre-process, in order for the data analysis, numerical Python library is very useful. And the skills that were required for the numerical Python is very useful. So let's see some of the functionalities that was there in the numerical Python. So in order to start this numerical Python, we need to first import this Numpy library. Numpy is also known as numerical Python. So firstly, let's import the Numpy and import Numpy as NP. I'll also import one more library called matplotlib. So I'll use this matplotlib library for the sake of visualization. For few functionalities, I will use these visualizations to explain their functional use. For that, I will use this matplotlib. So let's import matplotlib library. Import matplotlib as import matplotlib.pyplot as plt. Execute it. As soon as you execute the command, and this is what we got. And what I'm doing here is that I'm importing the numpy with the variable np. I'm importing matplotlib.pyplot with the variable plt. So now, what are the functionalities that was there? I can use this numpy library or np dot all the functionalities that was available for the numerical Python. Now let's start by creating an array here. Array. The definition of array is collection of elements with similar data type. Array is basically the collection of elements, could be numbers, float values, or even could be the list of values, but the data type should be almost similar. So that's what we need to be important in array. It could be the collection of integers, it could be the collection of float values, it could be the collection of strings. So that's what basically we have to be understand in the data type here. So let's see how to create an array. So I can create an array with a simple data type list. Let me create a list, my list. And what I'm doing here is that I'm creating a list of integers with 1, 2, 3, 4, 5. So this and all the collection of this and all are having the similar data type. So what I can do here is that I can convert this list is an element or an object into an array. So for that, what I can use is the library np.array array, and what basically it will do is that it will convert the objects into an array or numpy array. So what I'll do here now, list. Let me name it as in the variable arr. Now let's print the arr. As you can see here, I just converted the list into array. You can also look into the data type of array which is what numpy.nd array. nd stands for n dimension array. So this is how we can convert any object, could be the list, could be the tuples, into an array. And if at all you can look into the data type that was inside that. And for that, what we have is that arr.dtype is there, which will actually give you the what is the data type inside the list. So here you can see the data type is integer 32. So remember one thing, that here I'm giving you the list of values and which are in the integer. Suppose for example, let me add one of the element and could be the float values. Let me give 5.5, and what happens, this numpy array will basically convert the rest of the values into the float. Actually the values 1, 2, 3, 4 are the integers, but if I add one more element, float values, what it basically do is that it will convert entire data type into the float values. That's what the meaning of array. Array is basically the collection of similar data type. The data type should be almost similar. Now if you look into the data type, of course this is the numpy array, but if you look at the data inside that, and what is going to be here is it is converted into the float values. All right. Now let's see. Let me create one more array. We can also create an array something like this. np.array. I can create an array something like 1, 2, 3 in 5, and instead of this, what I can do here is that let me give a value abc. Now what happens to this abc is this. You can see actually the data type should be almost similar. Here I inserted the string value here, but this one all the same data type of integer. But if I convert that into array, what happens is that it is converted that into the string values. So you should be extremely careful that what is the data type and all you have to understand here. Now if at all look into this arr.dtype, and what it shows is that u11 is basically the string format. So this is how, how we create an array. In the next lecture, we will talk more about the creation of arrays. Hello everyone, welcome back. In the previous lecture, we talked about the one-dimension array. Now let's see how to create the two-dimension array in this case. So for example, we created the one-dimension array using one list. So in order to create the two-dimension array, what I want to do here is that I need to create a nested list. Now let's see how to create a 2 by 2 array. So I can create the 2 by 2 array with help of nested list. Let me create a nested list here. So I created a list with the square braces, and inside that let me create the list, and in that I'm having that 1, 2. And outside that let me create one more list here, and let me name it as 3, 4. So this is what the nested list with the 2 by 2 structure. So what is basically the entire thing is an array, and what are the list we represented inside that? It could be a row. This is the row 1, and this is the row 2, and this is the column 1, and this could be the column 2. So if at all if I convert that into an array, you can understand this. So let me use np.array, and let me convert that using this. Now we can see here, let me name it as array2, and now let's print array2. Here you can see that I created a simple two-dimension array which having the 2 rows and 2 columns. This is the row 1, and this is the row 2, and this is the column 1, and this is my column 2. This is how very easy I can create a two-dimension array. Here I list down the few methods. That is, nd dimension array means we have the end dim, shape, size, and data type. So these are all the methods, a few methods which will actually look into the shape of an array and also the data type. So ndim will basically represent the dimension of an array. So for example, array2 is basically a two-dimension array, and array1 is basically, or array1 is basically represents the one-dimension array. So let's see here, arr1 or arr.ndim, and if I execute this statement, it says that it is a one-dimension array. And let me check the dimension of array2. It is just basically a two-dimension array because it has rows and columns. In order to check that, and arr2.ndim, it basically returns the two-dimension array. And if at all you look into the shape of that, means how many rows and how many columns or how many elements are there. For example, if we have this array1, so if at all I want to like the shape of that, arr.shape, and basically it returns the 5 comma nothing. So this indicates that it is a one dimension array, and there are 5 elements in that. So that's the meaning of this. And let me check that arr2, this is the arr2.shape, and there are 2 rows and 2 columns. That's the meaning of this. The total there are 4 elements, and in that we have the 2 rows and 2 columns. That's the meaning of that. And if you want to look into that size, what is the meaning of the size will basically give you the product of rows and columns, or basically it will give you the number of elements in an array. So let me check that. arr.shape or arr.size is basically give you the number of elements in that. Obviously there are 5 elements in this. Let me check the shape of the or size of this, and it returns the 4. Basically, there are four elements is 1, 2, 3, and 4. There are total 4 elements is this. So that is what the meaning of that. Whereas the shape will give you the what is the shape, how many rows and number of columns, and this will return you the number of elements. So let me write down here. This will return you the number of rows and columns in two-dimensional array. And lastly, we have the data type. We already look into this data type here because we already saw this data type. Is basically we'll talk about what is the data type inside it. And let me check this ARR2, and this is my ARR2, and the data type inside that is a float integer values. So you can check that d type, and is basically the int32. If at all you want to name get the name of that, take the name of this. Int32 is what the data type inside the array2. This is my array2. Hello everyone, welcome back. In the previous lecture we talked about the one dimension array. Now let's see how to create the two dimension array in this case. So for example, we created the one dimension array using one list. So in order to create the two dimension array, what I want to do here is that I need to create a nested list. Now let's see how to create a 2 by 2 array. So I can create the 2 by 2 array with help of nested list. Let me create a nested list here. So I created a list with the square braces, and inside that let me create the list, and in that I'm having that 1, 2. And outside that let me create one more list here, and let me name it as 3, 4. So this is what the nested list with the 2 by 2 structure. So what is basically the entire thing is an array, and what are the list we represented inside that? It could be a row. This is the row 1, and this is the row 2, and this is the column 1, and this could be the column 2. So if at all if I convert that into an array, you can understand this. So let me use np.array, and let me convert that using this. Now we can see here, let me name it as array2, and now let's print array2. Here you can see that I created a simple two-dimension array which having the 2 rows and 2 columns. This is the row 1, and this is the row 2, and this is the column 1, and this is my column 2. This is how very easy I can create a two-dimension array. Here I list down the few methods. That is, ND dimension array means we have the end time, shape, size, and data type. So this one of the methods, a few methods which will actually look into the shape of an array and also the data type. So ndim will basically represent the dimension of an array. So for example, array2 is basically a two-dimension array, and array1 is basically, or array1 is basically represents the one-dimension array. So let's see here, arr1 or arr.ndim, and if I execute this statement, it says that it is a one-dimension array. And let me check the dimension of array2. It is just basically a two-dimension array because it has rows and columns. In order to check that, and arr2.ndim, it basically returns the two-dimension array. And if at all you look into the shape of that, means how many rows and how many columns or how many elements are there. For example, if we have this array1, so if at all I want to look the shape of that, arr.shape, and basically it returns the 5, nothing. So this indicates that it is a one dimension array, and there are 5 elements in that. So that's the meaning of this. And let me check that arr2, this is the arr2.shape, and there are 2 rows and 2 columns. That's the meaning of this. The total there are 4 elements, and in that we have the 2 rows and 2 columns. That's the meaning of that. And if you want to look into that size, what is the meaning of the size will basically give you the product of rows and columns, or basically it will give you the number of elements in an array. So let me check that. arr.shape or arr.size is basically give you the number of elements in that. Obviously there are 5 elements in this. Let me check the shape of the or size of this, and it returns the 4. Basically there are 4 elements, is 1, 2, 3, and 4. There are total 4 elements is this. So that is what the meaning of that. whereas the shape will give you the what is the shape, how many rows and number of columns, and this will return you the number of elements. So let me write down here, this will return you the number of rows and columns in two-dimensional array. And lastly, we have the data type. We already look into this data type here because we already saw this data type. Is basically we'll talk about what is the data type inside it. Now let me check this ARR2, and this is my ARR2, and the data type inside that is a float integer values. So you can check that d type, and is basically the int32. If at all you want to name get the name of that, take the name of this. Int32 is what the data type inside the array2. This is my array2. Hello everyone, welcome back. In the previous lecture, we talked about how to create an array, and also we look into the size, shape, and data type of an array. In this lecture, we will see a few methods that was used to create an array. So these are all the methods that was commonly used to create an array and also to save an array. The first one is array. This method we already saw in the previous lectures. And now let's see few other methods. Let's start with arrange. Arrange. Basically, we represent that with a range. Okay, a and range both are different. So a is basically an array, and this represents the range of values. So let me create the range of values. np.a range, and here you can see there is a start, stop, and step is there. Start will basically talk about what is the value I need to start with, and what is the value I need to stop it, and what is the step or what is the interval that each and every value is equally spaced. That's what we need to create here. So let me create an array. So my question is that create an array in the range of some 0 to 100. This is what I just want to create here. So in order to create the range of values in the range of 0 to 100 and all are integer values, if at all you want to create that, I can use this arrange. So let's say 0, and this is the start value, and the stop value is 100, and the step is basically defines the interval. And now let me name it as this is my array number 3, and let's print the array 3. And this is what an array 3. You can see here the start value is 0 and the stop value is basically the 100. We don't get the 100 values, but we are going to get the length of that is basically the 100. So basically it will skip that one value. All right, so this is how you can create an array with using a range. Let me create one more array, use the range, but here instead of that, let me create every alternate values or every fifth value I want to create starting from 0. And for that, I can use 5. So here there is a step defines the interval. Means the equally spaced means first we'll start with 0, and 0 plus 5 is 5, and 5 plus 5 is 10, and so on. So that's what basically you're trying to create using this. So let's see that. Now you can see here the first one is 5, and 0 plus 5, the step is 5, and 5 plus 5 is 10, and 10 plus 5 is 15, and so on. So this is how the values we can create in this way. We can also create in some different way. Like I just want to create values in the between 100 to 0. So I need to start with 100, and why do we want to end with 0 or something like 1? So that's what basically I want to do. It was actually the similar thing just like we do, but here I need to start with 100, 99, 98, and so on. In order to create that, what I'll do here is that start is 100 and stop is 0, and the work that was due by the step here. The step is basically used as an operator. So what will start with 100, and 100 minus 1, it will start with 100, and 100 minus 1 is 99, and 10 minus 1 is 98, and so on. That's what the step is keep on going here. So in every iteration, it was step of -1. Now that's what we are getting in this case. And if you print that, we start with 100, then 99, 98, 95, 97, and so on. So this is what the one of the use and advantages of the array. It's not only in this range, what are the specific range you want, you can also create this. So let me create one more array is between, let's say, 500 to 450, and so in the step of 3, and we can do that. So let's say 500 and 450, and step of -3, what I'll get here is the array number 5. So this is how, like, we can able to get the values using a range. In the next lecture, we'll talk another method of creating an array. Thank you very much. Hello everyone, welcome back. In this lecture, we will talk about Linspace. Linspace is similar to array, which will create the array in this particular range. So let's see how to use this Linspace and create an array. So let me use np.arrange or np.linspace, and there is a Linspace is there. And what it is actually doing is that it has a start, stop, and there is no step here, but instead we have something different thing called num. Num indicates there is how many points you want between start and stop. So by default the num is 50. So let me create an array. Let me create the values between 0 to 100, and let me create 50 values here. So basically num is equal to 50, and let me name it as array6, and let me print this array6, and this is what an array6. As you can see, we got the 50 values between 0 to 100, and we have 0 and also we have 100, and in between that it will do the equally spaced between the 0 to 100, so that we can have, like, all the 50 values here. Again, you can also specify the n number of values you want. Let's say I want 200 values between 0 to 100. It will automatically calculate for you and give the results. So this is how, like, you can use this numpy Linspace to generate the list of values or array of values between the specific range. So this is one of the most useful, and there is one more thing is that endpoint is equal to true. By default, the endpoint is equal to true means it asking you whether you want this endpoint or not. If at all, if I specify the endpoint is equal to false, and what it will do is that it will ignore the final value, or it will ignore the endpoint, so that you can get the list of values or the array of values between the specific range and the number of point as you have requested. So this is what the Linspace, and it's one of the most useful command while dealing with or generating the sequence of numbers and in the specific order. Hello everyone, welcome back. Let's try to understand another method called zeros and zeros like. Zeros and zeros like is very useful method when you're initializing an array. So let's say how to create a zeros array. So np.zeros, and now what you can do here is that you can look at the shape here. The shape will talk about, like, what is the shape of array and the zeros you want. Let's say I want to create a 5 by 5 zero matrix, and you can create a zero matrix something like this. So zero mat is generally the zero matrix, and you can create the 5 by 5 zero matrix using this. It's very simple. The matrix is very simple technique in which we'll able to create a zero matrix something like this. So this is really useful whenever you want to create the n number of zeros. If at all you want, it will automatically create the zeros as you wish. And there is another method is called a zeros like. Zeros like is very useful compared, just like the zeros, it's also very useful. For example, you don't need to specify the shape, and you are getting the shape in some other way, or you want to capture the shape of the array of some other matrix, then you can do it. For example, let me go up, and I created some two-dimensional array. For example, this is a two-dimensional array which I created this, and I want to create the zeros like the shape that was there in the two-dimensional array. So let me go to my step here, and this is the AR2, which is what my two-dimensional array. You can look into the shape of that, and which is a 2 by 2. So you don't need to specify the 2 by 2 here, and if at all you don't need to specify something like this, then what you can do is that np dot zeros like, and basically zeros like, which will take an array. Let's say if we take an array 2, and it will basically consider the shape. You can look into the, consider the shape of the what of the array we have, and it will create a matrix for you, zero matrix for you. So let me say like 0 mat 1 is equal to this, and since it is a 2 by 2 array, and we'll get the shape of two zeros of 2 by 2 matrix, something like this. So this is a very useful technique in order to create a zeros. So this is all about the zeros and zeros like. Hello everyone, welcome back. So in this lecture, we will talk about ones and ones like. Just like the previous lecture we have seen, zeros and zeros like, we have the similar thing like ones and ones like, which will basically create the ones. So let's see how to create the ones matrix here. So ones mat is basically equal to np dot ones, and what will basically create is the ones in the specific shape. So let's see, like, I just want to create a 5 by 5 ones, and I can simply create the ones matrix, something like specifying the shape here. So what you can see here, I can get the shape of the ones, and with the specific shape 1 comma 1, and all are the ones here. And similarly, just like the zeros like, we have the ones like is there, we can create the ones like here, something like this. So what I can do here is that once mat1 is, I suppose I want to replicate the shape of the array 2, then I can use this ones like. So let me take the ones like array 2, will basically take the shape of array 2 and return the ones for you, something like this. And this is especially very useful whenever you want to do some kind of operations. And for example, I just want all 3 by 3, all the values inside the array is 3. And then what we can do here is that I can take this ones matrix, and I just simply multiply with 3, and will get all the matrix in the same set. Basically we are creating a similar matrix, something like this. All right, so this is how we can use this ones and ones like. And the next lecture we will talk more about the numerical Python. Thank you very much. Hello everyone, welcome back. In this lecture we will talk about random and random generator. So this is very useful function. It is used in the many techniques. For example, if at all you want to train the neural network in order to initialize the weight, we will use this random generator to initialize our weights. And at the same time, for the indexing, and at the same time for splitting the data, we can use this random. If at all you want to do the random sampling technique, you can apply this random. So very useful technique for creating and also for splitting an array. So let's see how to do this random here. So let's start with the random. So in order to get the random here, what I can use here is that np dot random, and random dot, there are different kinds of random generators are there. So we will see one by one. So let's start with the first random technique is randint. Randint will basically generate the list of values in a specific range. For example, I want to generate the random numbers is between the low to high, and I can use this np dot random dot randint, and this will actually generate the uniform distribution of values. So let's see, let's generate the random numbers, let's say in the range of 0 to 100, and I just want to generate the uniform normal distribution values. And at the size of that, let's say I want to generate the 1000 random numbers. So let's see, like now let me name it as AR1, is basically the array of random numbers, and will generate the 1000 random numbers. And let me print this AR1. Now you can see that we created an array in between 0 to 100, and all the numbers, what are the generation is uniform. Uniform distribution is basically you are getting the values in the uniform distribution, means each and every value has the really good chance of being selected. Now that's what the uniform distribution is about. So what I'll do here is that let me, for the sake of the simplicity, what I'll do, let me plot it. So I can use this matplotlib library. So here, make sure you have already imported this matplotlib, and using this matplotlib library, I can plot the histograms using that. So let me use this histogram. So plt.hist, and I can use the array1. All right, so what I have is that I've generated the uniform normal distribution. Instead of this, what I can do here is that basically here I need to select the number of bins here, but we have the one more um, library that was there, which is already installed with the Python, that is actually called cbon. So let's import the cbon, and that will actually give you some kind of functionalities, and it will automatically calculate the number of bins. So let's import the cbon first here. So let me import cbon as SNS. So I just import the cbon just for the sake of visualization, and let me generate the distribution plot using this. So the distribution and the values that I'm using for the distribution is AR1. So that's it. So let me plot it. Now as you can see here is that we got the uniform normal distribution, and we got some kind of line. This is called kernel density estimation, and in order to use that, what we can do, in order to remove this, what I can use is that I can use this KDE equal to false. All right, so this is what I'm getting here. I'm getting some warning here. It says like, the this plot is getting the deprecated. So in order to use that, you can use, okay. So this plot is basically will get this deprecated and may not be available in the future versions. And however, they have given you the new method is hist plot, and we can use this hist plot, I guess, is basically the histogram, and which will return you the histogram and the number of bins. You need to select the number of bins and to automatically create the bins for you. So this is how we can simply able to plot and the cbon is very, very nice way of bringing you the technique here. So now let's see another method of generating the random numbers. So we already have the random numbers, but actually there are so many random numbers that we can able to use. And this is basically called uniform random int is basically it will create, let me write down here, it will create the uniform random distribution. Basically it will create the random numbers in uniform distribution. Okay. So we have the different kinds of distribution of generating the random numbers. So let's do one thing. What we will do is that let me try to initialize the random function so that now we can generate the so many values you want. All right. So what we will do, let me create the generator function. Let me create the generator function is np.random.default generator, and with this I can create the generator function something like this. Now let me take this generator function dot, and there are so many kinds of distributions out there: beta distribution, binomial distribution, chi-square distribution, choice, exponential, f, gamma, and so many kinds of distributions are there. So what we will do here is that let me try to explain you few distributions which are most widely used distribution. All right. So what we will do is that let me start with the distribution called normal distribution. Normal distribution is also known as the Gaussian distribution, and where we need to specify the mean, and also we need to specify the standard deviation. So in order to generate the Gaussian distribution, let me use this Gauss, and this is the Gaussian distribution, and here we have the random normal Here we have this normal is there, so this will basically create the random numbers in the normal distribution. Here you need to specify the two things. One is LOC and second one is scale. LOC is basically the mean and the scale is basically denote the standard deviation. So LOC, let's say I just want to generate the random numbers, that is in the form of the uniform, that is in the form of Gaussian distribution, where the mean is equal to 10, and let's say if at all you want the standard deviation, and that is equal to scale, and the standard deviation is, let's say you want the three times standard deviation, and you can generate this. So what I'll do here, for the sake of simplicity, I'll take this mean is equal to 10 and standard deviation is 3, so that it is easy for you to understand here. So let me take mean and let me say it is std. Now you can generate the what are the range of numbers you want. Let's say I'll specify the size, and the size I just want to specify here is let's say I want 1000 random numbers. I want the 1000 values is between in this particular range, or 10,000 numbers. Okay, so you can generate a number of range you want. That's it, it will automatically generate that. And just remember, it is not a normal, it is not a uniform distribution, something like this. It is a Gaussian distribution. The random numbers whatever you get here is the Gaussian distribution, and the most of the values is being surrounded to our mean and with the standard deviation of 3. Okay, so that's what basically we are trying to get here. So in order to visualize this, I can use this like you see SNS dot histplot. I can use a histogram, and the data that I need to specify is Gauss. That's it. So now you can see it will nicely plot the histogram for you. So what I'll do here, plt.show, it will basically gives you the histogram, and it's more or less looks like a normal distribution. So as you can see, the mean here is 10, and this with the standard deviation of 3. And what you can understand is that within the 3 times standard deviation, we have 99% of values. Means 3 times standard deviation is 3 into 3, that is equal to 9. So in the range of 9, so from here to 9 and from here to 9, so from here to 9 is almost equal to 1, and from here to 9 is almost equal to 19. So between 1 to 19, we are having the 99% of values. That is what automatically we can able to see in this case. So it's a very useful function that is useful to generate the normal distribution values. Hello everyone, welcome back. Now let's see how to do the Poisson's distribution, or how to generate the random Poisson's distribution. Poisson's distribution is particularly useful whenever you deals with the time. For example, this is what the Poisson distribution, which is what the probability of x is equal to k. K is basically the number of events, and which is equal to the lambda power of k e to the power of minus lambda by k factorial. So lambda is basically the mean occurrence of that particular event is happen in the specific interval. So this kind of distribution is basically called the Poisson's distribution. It's very useful whenever you're dealing with the time and the mean occurrence in that particular time. And of course, the heterogeneity of the Poisson's distribution will follow the gamma distribution. So what we'll do here is that let's see the Poisson's distribution for all values of k and all values of lambda. So let's look into that and let's see how to do the Poisson's distribution. All right, so we did this generator here, and let me have this generator function here, and here let me take this Poisson's distribution. So this is also one of the most widely used, and there we have is that lambda is there, and that lambda will basically specifies the mean occurrence of that. So what we can see is that I can specify the lambda, and lambda is basically the mean occurrence of that particular time. Let me say I just want to look into the mean occurrence around the 10 and with respect to the time, and let's say I want to generate like 10,000 samples, and this is what my Poisson's values. So Poisson's distribution, so this is my Poisson's distribution. I'm generating the 10,000 samples this time, and now let's try to plot the histogram for that, and that is going to be equal to something like this. So SNS dot histplot, and I'm drawing the Poisson's distribution here, and plt dot show, which will basically gives you the Poisson sample. And as you can see here, like most of the data and the most of the samples is occurring around the 10, and we are getting the minimum number of here, something like this. And of course, we can also set, like let's say if at all you want to happen the most number of events that is to be happen somewhere between in 5, and we can use this. So I can set the most number of events in this, that's my lambda. And now you can see that we can get the 5, and of course there is no negative values in the Poisson distribution, so that's why around that it's going to be equal to 0. And for example, if I set that lambda is equal to 1, and we'll get the most of the samples at 1 and something like this. So this is how, like you can generate the Poisson's distribution of data. So very useful distribution. And whenever you're dealing with the time, or whenever you're dealing with the customer lifetime value predictions, and whenever you deals with when the customer next buy prediction, etc. All right, so this is a quite useful distribution, is used in the many applications. Hello everyone, welcome back. And now let's see the gamma distribution. Gamma distribution is also one of the most widely used distribution. So now let's see how to generate the values or random numbers based on the gamma distribution. And let's go here, and there is a one more distribution, gamma distribution. In the gamma distribution, this is what the gamma formula is. Gamma of alpha is integration to 0 to infinite e to the power of minus lambda and lambda power of minus alpha minus 1, where lambda is actually the Poisson's mean. Here we have the lambda, it's actually the mean occurrence, and there is a one more factor is called shape factor, that is alpha. And the gamma distribution, basically we have like shape parameter and also the scale parameter. And that is basically if you include the scale parameter here, and so what you'll get here is that is the function of the gamma is basically the function of alpha comma beta. So where alpha is the scale parameter, the alpha is a shape parameter and beta is a scale parameter. Okay, so we can use, and the heterogeneity of that will follow the geometric distribution. So let's see how to generate the gamma distribution with random numbers. So just remember, we have the two parameters. One is the shape parameter and second one is the scale parameter. All right, the scale parameter will basically adjust the x-axis, and the shape parameter and will basically makes you the from the reduces from the skewness to the normal. All right, so let's see the generator. Let's take the generator again, and this is for my generator dot, and we have the one more distribution is gamma distribution, and here we have the two parameters. One is the shape and second one is the scale. So shape parameter is we can set what are the shape parameter you want, and that's basically represents the alpha. So the lower the value of alpha, the more skewness we have. So let's say the shape is equal to 1, and the scale parameter basically defines the what is the scale of your x-axis. If scale is equal to 1, it is basically equal to the gamma of alpha. So in this formula, if beta is equal to 1, and it's basically equal to the gamma of alpha. Okay, so make sure like specify some other values of beta, so that you can get you can look at the shape. Okay, so let's go back. So if at all if I put this, and this is basically the gamma, in which is actually the gamma of alpha, I think, but the n-1 factorial. Anyway, what we will do here is that let me generate the gamma here, and how many values I want. Basically I just want to specify the size, and I just want to generate the 10,000 values here. All right, so now let's look into the shape of that. And remember, the heterogeneity of that gamma distribution will basically looks like the geometric distribution. So we'll have the more and more skewness. Okay, so that's what basically you have. So more and more skewness is what basically is possible with scale is equal to 1. And as the scale as the alpha shape parameter increases, we'll get the norm distributed normally, and you'll get like something like the Poissons. Okay, so what we will do now is that let's take this SNS dot hist plot of gamma, and we'll get plt dot show, and you can see here this is what the gamma distribution. It's more looks like something like this. So much more looks like the heterogeneity basically follows the geometric distribution. And as you basically increases the shape. Let me check, let me take the one more thing, and let me take one more value, which is basically the gamma of 1. And here what I'll do, I'll generate the series of values here, copy and paste it, and here. So here what I'll do here is that let me increase the scale here. So if at all increase the scale, basically what happens here, you can see the default scale, if I use the scale is equal to 10, and it will be in the way in this particular range. So if I use the scale is equal to 10, the scale is going to be increases 10 times. So now you can see that scale is increases to 0 to 10 to 0 to 100. It increases 10 times. If at all you want to increase 100 times, we can get the increase of scale to 100 times. So that's what the scale will basically is all about. And the shape parameter will actually reduce the skewness in the distribution. So let me copy and paste one more thing, and this is my gamma 2 will basically uh, in this case, I'm just trying to adjust in the shape parameter. Shape parameter will try to reduce the skewness and make your data more like a normal. So let me increase the shape to let's say 10. And here you can see here it's more or less looks like a Python's, and where you can see like it's the skewness has been reduced a bit. So for example, if I make it to 100, or not 100, for example, if let's make it to 50, it's much more nearer to the normal distributions. So that's what basically the shape parameter is all about. Okay, so if it all increases to 200 here, what happens is that it's equally gets shifted basically. Let me use 1000, and this is how it's more and more and more, it looks like a normal distribution. So that's what the gamma distribution is all about. In the next lecture we'll talk more about the hello everyone, welcome back. In this lecture we'll talk about the beta distribution. This is beta distribution is one of the convenient two parameter function, and it is most widely used distribution to generate the what are the shape you want, we can generate with the beta distribution. So let me go back here, and the beta distribution, if at all you can see, we can generate the normal distribution, we can generate the skewness on the left side, and we can generate the skewness on the right side. We can generate almost all possible shapes can be generated with the beta distribution. It is a two parameter mathematical function, and it was the range of 0 to 1. It's particularly useful for the probability values and many more. And this is most widely used two parameter distribution function. So we can generate what are the values you want, you can generate it. Okay, let's see how to generate the beta distribution of random numbers. So let me take the beta here and the generator, and what I can use is that I can take the beta here. So beta is widely used normal distribution. It's a two parameter a and b. Okay, so let's see, like let me generate the two parameter. For example, let me generate this blue line where like if a is equal to 0.5 and b is equal to 0.5, we'll get this kind of shape here. Okay, let me name it as a is equal to 0.5 and b is equal to 0.5, and how many values I want. Basically I'm looking for 10,000 values. Let me have the 10,000 values, and let me name it as beta 1, and let's generate the value 10,000 values of this particular shape. Now let's see that sns dot hishplot. Now this is my beta 1 and plt dot show. All right, now we can see it is a two parameter function where we can generate such kind of shape here. So let's see one more kind of parameters like of alpha and beta. So let me take 2,8, and we can get the skewness something like this. So let me copy and let me paste it here. And what I'll do here, this is let me put a is equal to 2 and b is equal to 8, and let me generate the some 2 here. And here what I'll do is that sns dot hishplot, and it's my beta. So I'll take the beta 2 and plt dot show. So let me execute that. Oh, we got 2,2. Basically we'll get the equal distribution. If I take beta is b is equal to 8, we'll get the skew something like this. So this is what is possible with this. And if I put 3 comma 3, we'll get the perfect normal distribution. So we can get the perfect normal distribution kind of the random generators using the beta distribution. So 3 and 3, and this is my beta 3. So we can get the perfect normal distribution, or some kind of bell-shaped curves kind of distribution can be generated with this. Let me take one more. And so what it is basically, it is how we can get, like, we can generate the negative tail distribution of data. And what we can do, we can give this lower value to we can give the higher value to 8, like a, and the lower value to this, and we can get such kind of distribution. Let me name it as beta 4 and execute it. So perfect. Now we can see we can generate the different shapes of the random generators with the beta distribution. So beta is most widely used two parameter, and it is a convenient mathematical function. It's most widely used distribution function. And the good thing is that we can get in the specific range of 0 to 1. So that is how, like, it's a very useful function to generate the values in the specific range. Okay, so this and all, like, most widely used random generators. So apart from that, we can also have the different kinds of generator. So let me take the generators here. We can have, like, binomial distribution, chi-square distribution. It looks like the positive skew, and Dirichlet exponential distribution, F distribution, and we already look into the gamma, and we have the geometric distribution. It's much more similar to the gamma. And so many kinds of distributions are there. I recommend to look into the documentation of the Numerical Python, or else you can also try on your own. So this is what, like, for you can also try what are the distributions you want. Like, binomial is basically the it's almost similar to the normal distribution, but here we'll give you the values like we'll give you the values like n number of samples. So total n indicates the total number of experiments, and p is what the probability of success. So for example, I'm doing some 100 experiments, 100 100 experiments, all are of equal, and what the probability of the success is, let's say, 0.5, and this number of values I just want interested is 100. So, or 10,000. Basically this will create the normal distribution. Okay, so this is binomial. So binomial distribution, bino, and I can see like, histogram of this bino in the plt.show. So that's basically looks like the normal distribution. It's basically the discrete version. Binomial distribution is a discrete version of your normal distribution or the Gaussian distribution. This is the Gaussian distribution, and the discrete version of that is going to be your binomial distribution. So this is how, like, you can generate the binomial distribution, and there are many distributions out there. I request you to try all such kind of distributions, so it will be very useful. All right, so this and all, like, few techniques that are most widely used distributions. So in the next lecture, what we will do, we'll talk more about the numerical Python. Thank you very much, and we'll see you in the next lecture. Hello everyone, welcome back. So in the previous lecture, we talked about the random generators. So now let's see one more methodology which was there to create an array is from function. So this is also most widely used methodology to create your own functions. So instead of using that, you can also write your own function of generating an array. So let me create my function. For example, this is what an array I just want to create in this case. For example, I'm having array 0 and array 1 is there with me. So this is the, sorry. For example, I'm having this array, and this basically indicates the row number, or this basically indicates the column number. Now I just want to create an array something like this. So 0 plus 0 is 0, and row, I just want to create an array something like row plus column. So for example, 0 plus 0, I'll get 0, and 0 plus 1, I'll get 1, 0 plus 2, I'm getting 2, and 0 plus 3, I'm getting 3, and 1 plus 0, I'm getting 1 here, and 1 plus 1 is 2, and 1 plus 2 is 3, and 1 plus 3 is 4, and something like this. So this is what basically I just want to create in this case. So remember, the from function will basically take the, by default it takes the inputs, rows and row number and the column number. Okay, so let me define this. So what I will do, I'll create a function something like add row and column. So the by default I'm getting the row, and basically the row number and the column number is what the two inputs I'm getting here. So what I want to do here is that I'll do some addition. So let me name it as the rest is what my addition. So row plus column, and let me return this, and res. So basically I'm doing the addition of two numbers. So if at all I pass 0 and 0, I'll get this, 0 and 1, I'll get this, and so on. So let's say I just want to apply this from function. Okay, so I can use this numerical Python. So np dot, and there is a from function is there. You can see there is a from function which will take this function from function what, this is what my function, add row comma column. By default it will, by default what it will do is that it will take this rows and column, row number and the column number, and you can construct the array something like this. Now what is the shape you want? The shape I just want here, it is 3 rows and 4 columns. So this is what an array I just want to create. So let me name it as an array func is what my the array function, array fun. You can see, like, I have generated this. So it is basically the row number plus column number. All right, you can also do the multiple functionalities like the multiplication, row into column, and mul row into column. You can also take this. So many things, many functionalities you can create it. So array func1, and here in this case I'm just adding the this kind of array, and you can see I'm just generating some kind of functionality something like this. It's basically the row number into the column number is what basically we add, and we'll getting some matrix something like this. We can do many things using those kind of functionalities. I can generate any number of array, like probably like 5 by 5 or 6 by 6 or so on. So this kind of matrix which I can able to generate using the from function command. So this is about this from function. In the next lecture we'll talk more about the numerical Python. Thank you very much. Hello everyone, welcome back. In this lecture we'll talk about one more thing. Function is npy and npz. These are all the two functionalities which are very useful to save our Numpy array. So we can save our array, whatever array we have created, we can save our array either in npy or it is in npz. npy will basically use to save only single array, whereas npz will basically save in the zip, and we can save the multiple arrays. For example, let's say I just want to save this array using npy. So in order to do that, I can use this np.np save, and we have the save is there, and what we have is that we can use the file format. What file I just want to save here is that, let's say I just want to save my array, and it is function, and the format that is basically is very important. It is used to save in the format of npy. Okay, now numerical Python is what the extension, and so what I want to save here, what is the array I just want to save here is this. So that's it. So this is how you can able to save your array. So let me open the array. So that's it. You can see here I can able to save my array in npy, and the size is nearly equal to 328 bytes. Even I can load that. So in order to load it, load an array. So I can use this np.load, and we have the load is there, and which is helpful to useful to load. And this is what the function I just want to, I mean, this is what the data I just want to load. And I can load it here, let's say ar2 or some function, and ar2 underscore function. I can simply load back the data using this numpy function. So very, very useful function in order to save. And there is a npz is there. The npz, it's basically used to save for the multiple arrays. Okay, for in order to save the multiple array, you can use npz. So let me save the multiple arrays. Let's say I just want to save ar1, and I just want to save ar func, and I want to save some kind of distributions like a beta, gamma, and so on. Let's see like all these things. So let me use np.save. Here there are different kinds of saves out there. I can have to use this save z or save z compressed. You can use both the case. Save z compressed is basically compress your data. So I'll use a save z. So here you can look into the functionalities here. So the file name that what you want to, it is basically an uncompressed one. So if at all you want to compress, you use this compressed. Okay, so let me save the arrays dot npz with this, which is not the compressed one. And you can write on the group or list of array whatever you want. So it was an augments. So I just want to save these. I just want to save one more array. Let's say array1. This is what I just want to save. And let me write down some kind of functions. Look, we have is the gamma, and we have the beta, and many more. Okay, well, let's say I just want to save this, and if at all I want to save, I can simply save. And remember that what are the things we have saved, and this is an uncompressed. This is not the compressed one. And if at all you want to save in the compressed, what you can use is that save compressed. This is how you can use to compress your data, the same data, array, function, and gamma, beta. But here you can see the data is being compressed at least like some bit. So if at all the size is big, you can see a lot of difference. In this case the difference is not much, because the data, what are the data we saved is more or less like random numbers. Anyway, so this is how we can able to save. Let's load the data. So in order to load the array, and load z, and let's say I just want to load this array zip, and same function we can use np.load, and I can use this and load it. But in order to load this, we can't directly get out of this values. For example, if you have the 3 files out there, so in order to get this, so you can take the fields here. There are files out there. There are 3 files that is being saved: array0, array1, array2. So what are the sequence that is being there? It is what the sequence it is being stored. Array0 is what my array ar func1, and array1 is my gamma, and array2 is my beta1. So let me load this. So what I'll do, this is my dictionary. In let me, if I give like an array underscore 0, and that is going to be my ar func1 is what this. And similarly, if at all you want to get this gamma, just give this 1, and you get all the values of the gamma distribution, and so on. So this is how you can save the values in npy and also in npzip. All right, so you can also save the values even in the text files. So for that you can use save in text. So for that you can go for like np.save. There is a save text is there. You can save that the text, and what are the name you want, and what are the format. And by default it is like 0.81, so 18 decimal points is being saved by this, and the delimiters, so everything is made there. So what I'll do here, I'm going to save the array is my array func1 is what, and I will just want to save here, and the file name is array.txt, and this is what I just want to save. What are the array I just want to save? You can save that array. Now let's execute that, and you can check your array here. You can see array.text, it was being saved, and there are by default it will give you the 18 decimal points. By default it will give you the 18 decimal point, will take a lot of memory. But instead, if at all you want to change to only the 2 decimal points, so just change it to fmt is equal to so it is a percentile, so it is a percentile 0.2f. That's it. So it will take only the 2 decimal points, or 0.2. E basically the scientific notation, f is basically the float values. You can save in that way. So I'm just convenient for us to save in the float values. Now we can see we can able to save the 2 decimal points of the float values. It's much more convenient way to save our data. Even if at all you want to save even the integers, we can save that. The format is the percentile d. If at all you want to save in array, you can also save in integers. So this is also the most convenient way of saving and also storing saving a lot of memory in this case. So here you can see this is what my the array. As you can see, the int is basically stored in 58 bytes, and the array text is basically took around let me check that, it is 133 bytes. So it takes around 133 bytes, but integer only takes 58 bytes. So you can see the integers saves the memory. So this is only the integers. All right, so this is how, like, you can save your data either in numpy y, numpy zip, or in the text format. So this is about the numerical Python on saving your data. In the next lecture, we will continue more on numerical Python. Thank you very much. Hello everyone, welcome back. In this lecture, we will see how to do the arithmetic operations in NumPy. We can do a lot of arithmetic operations. What are the operations I have seen? I have shown you in this lecture. We can do a lot more than this, but here I'm going to show you a few arithmetic operations that will be very useful for you. So addition, subtraction, multiplication, division, transpose, inverse, and reciprocal, power and remainder, this and all the arithmetic operations, I will show you how to do that in NumPy. So let's start by importing the NumPy. Import NumPy as NP. So now let's do some addition operations. So we can do some simple addition operations either by using like a plus operator, a plus b, or something like this. So we can use 2 plus 2 or 2 plus 3. That is what we can do. But we can also do some arithmetic operations using NumPy. So let's do some arithmetic operations. So np dot add, we have an add is there, so that will do basically some arithmetic operations. We can do some 2, 3. So what you can get here is that we can able to do some operations even in the even with the simple values. The basic difference in doing this and also the previous method is basically the time complexity. So here we have it will take the lesser time compared to the previous one. All right, so we can also do this arithmetic operations even for the arrays. Even for the arrays, we can also do some arithmetic operations. So let's import some uh, array, and then we will do some arithmetic operations here. So let's create an array. I'll use an arrange, and with this arrange, let me generate the range of values from 1 to 10, and with the default step of 1. So I'm generating this array, and let me name it as A. So this is my A array, and what I can do here is that I can do some arithmetic operations to that. So let me do some addition. So if I do A plus 5, so what it will do is that it will do the element wise operations. So means for each and every element it will add with 5. So let's look at the results here. As you can see, it will going to add 5 to the each and every element. For example, in this case 1 plus 5, 2 plus 5, and 3 plus 5, and so on. So this is how we can able to do the element wise operations in NumPy. It's very useful and handy. Instead of that, we can also do the two matrix addition of two matrix. So let me create a matrix here. Let's say I just want to create a matrix using the random numbers. Let me say b np dot random dot randint, and I just want to generate the values from between 0 to 10, and I just want to create some 3 by 3 array. So that's my b. And what I want to do here is that I just want to add some element or 5. So what it will do is that it will going to add each and every element to that, so that we can put each and every element to 5, and means 4 plus 5 and 3 plus 5 and so on. So this kind of operations we can also do, and also it can also do the uh, matrix addition. So let me create an array here. So let me name it as C, and this time I'll create one more array randomly, and this is what the array which I created. So this is my B and this is my C. I can able to do some matrix addition. Let's say B plus C is basically the matrix addition. So what you're doing here is 4 plus 3 and 3 plus 7, which is nothing but 10, and so on. So this is how we can also do some addition operations in this. So this is one of the most coolest thing, so which is being used in the many cases, like if at all you want to add the multiple elements, so we can also do that. Hello everyone, welcome back. In this lecture we will talk a few more arithmetic operations, that is subtraction. So we can also do the matrix subtraction, like element wise subtraction. Let's say this is my matrix A, and we can also do the element wise subtraction. Let's say I just want to subtract everything with 3, and we can also do that. So this is what my element wise subtraction, and at the same time we can also do the matrix subtraction simply by B minus C, which is my matrix subtraction, where B is equal to this and C is equal to this, and C we can simply able to subtract an array, something like this. So it's one of the very simplest thing which we can do is some matrix subtraction. Instead we can also do the subtraction using the function np dot subtract. So we can also do that. Np dot subtract just pass the arguments, that is B and C, and what it will do is that subtraction just like this. Okay, the main difference between these two is basically the time complexity. If at all you want to calculate the time complexity, percentile time it, and this operation is basically takes how much? It's 521 nanoseconds, whereas this operation will take percentile time it. So this operation will going to take 564. So basically the Numpy will be work better for the bigger data. I think it should come slower, but anyway, but generally the Numpy will be good whenever your array is very high, very big. There you can see the real-time complexity, it will be very small. All right, so that's what we can do in subtraction. When we can also do some multiplications. So in multiplication we can do the matrix multiplication, either dot product, or also we can do some element wise operations. So those things you will see now. So there are two kinds of things. One is a element wise, and second one is the dot product. All right, so what we will do is that element wise operations. So let me have an array of this, and if at all I want to multiply each and every element with 2, I can easily multiply that. So a into 2, this is basically the element wise operations, element wise operation, those things we can do. All right, so we can also do something like this. Let me have an array this, and let me create an array D, and which is in the range of just like that. Probably this is in the range of np dot arrange, and I just want to create from 11 to 20. Okay, this is what an array I just created, and this is what my A. And if at all I would just want to multiply these two arrays in element wise, something like 1 into what is that, 1 into 11 and 2 into 12, 3 into 13, we can also do that. So how? So it's simple, like A into D, and we can simply do that, like 1 into 11 is this, and 2 into 24 is this. So we can do all the element wise operations with the multiplication with simple start. Also we can also do the element also we can do some matrix. So for example, I just want to do the element wise operations in B and C. This is my array B and this is my array C, and if at all I want to do the element wise operations, something like 4 into 3 and 3 into 7 and 1 into 7, so those things also we can do. So simply B into C will basically do the element wise operations in this case. So for example, what is this? So it is a 0 into 4 is 12, and 3 into 7 is 21, and 1 into 1 is 1, and so on. And if at all you want to go for the real product or real matrix multiplication, you need to go for the dot product or product. Okay, so what this dot product will going to do is this np dot dot, they have the dot is there, so which will basically will do the matrix multiplication or the dot product of two arrays. So we can see B into C, and what is basically it happens is that it will do the dot product, or it basically what happens is that 4 into 3 into 1, and which basically it will get 4 into 12, so not this, 4 into 3 is 12 plus 3 into 7 is 21 plus 1 into 1, and this, and what it try to do is that it will try to add all these things and we'll get the 30 here. So that's what the matrix multiplication we can perform here, matrix multiplications. So this kind of matrix multiplications we can easily perform using the dot product. Okay, so this is a simple matrix multiplication. We can also do that, and apart from that we can also do one more arithmetic operations is division. So we can also do the division here, and let me take an array. Let's say this is my array, and similarly we can do the element wise operate. Just basically the division is basically the element wise operations. So we can do the element wise operations here. For example, I'm having the matrix A and I have the matrix D with me, and I just want to divide A by D. We can do that. A by D will basically divide it. This is basically do the division operation. So what it is, 1 by 11, 2 by 12, and 3 by 13, and so on. So those kind of things we can simply do that, or we can also have np dot division, which will basically do divide, which will basically give you the element wise operations just like this, A comma D. So you can do the both the same things or same, but one thing is that the time complexity will comes with here. All right, so this and this both are same. We can do the all the arithmetic operations as subtraction, addition, division, everything can be do in this case.